Before we discuss the actual code, I think it's important to look at the dependencies that I will be using for this project. That can be found in the requirements.txt file, and I think the most important one is the AWS CDK lib, which is at version 2. I'm also using Boto 3 along with python.env. So jumping into the app.py file, as you can see, I instantiate all the stacks that I will be using and deploying inside this file. I also have variables that I pass into my stacks. Most of it is S3 bucket and the 3 different lambdas and their names. And I also have my account ID and my region. I didn't want to expose my account ID or my region, so I passed it into my, I obtained the values from my environment variable file, which could be found right here, .env. I put an example env, and it just contains the account ID and the region, which are the 2 most important things that you need. So you can just create your own .env and put those 2 values in there, and it will pick it up from this props variable. So again, this file is going to represent all the different stacks that you will be deploying into your AWS account. So let's go over the stacks, right? I have multiple stacks. I think I have 6 of them. The first one is IAM roles. So this stack will include every single IAM role that I'm creating for this project. Furthermore, these are the properties that or the arguments that I'm passing into the stack. So I have my app, my constructor ID, my environment, that includes my account ID and my region. I have my stack name, and I also have a bunch of other variables that I will use inside this stack. I also have an S3 stack with similar parameters. I have an SQS stack, a Lambda stack, a Lambda event source stack, and API Gateway. So throughout this video, I'm going to go through each one of these stacks and explain what they do. So let's jump right into the IAM roles. The IAM roles stack contains the 4 different IAM roles that we're going to be creating and utilizing throughout our CDK project. The first one being the CloudWatch role that will be assumed by API Gateway. The CloudWatch role will have basic log permissions, such as being able to create logs, log streams, etc. As you can see, the actual log name is under role name. There is a description and the assumed by. These are all basic properties that the AWS IAM.role requires you to pass. Furthermore, the 3 different Lambda execution roles, they also require obviously a role name, and the rest are optional, but the inline policies are the most important. All 3 Lambda roles require basic execution permissions. That includes being able to create log groups and put events and to create log streams. So this AWS basic execution role will be duplicated or will be required for the other 3 or the other 2 Lambda roles. So just keep that in mind. Now the thing that changes is this AWS Lambda SQS polar execution role. So as I stated previously at the beginning of this video, this Lambda container needs to be able to receive messages. That is why the actions are set this way. So it needs receive permissions, receive message permission, get queue attributes, and also the ability to delete messages. Furthermore, the Lambda SQS checker needs the send message since it's sending messages to the SQS, and it also needs get queue URL permissions. Now if we go down to the Lambda training execution role, this Lambda will be talking to the S3 bucket, so these are the permissions that it will need. So things like put object, get object, delete object, etc. So at the end of this file, we have to essentially point out the resources that we want to be able to use in our app.py file. So that's why here I do self dot the actual name of the Lambda, and then I set it equal to the name of the Lambda that I set up here. And the reason why I do this is by doing this, we're able to access these AWS roles so that we can use them in our Lambda stack. That's the purpose. So now let's go to the AWS console to kind of show you what's going on behind the scenes. Going into the AWS console and going under CloudFormation, we could see all the stacks that we deploy into our AWS environment. Now, I haven't shown how to deploy the stack, but it's as simple as typing in CDK deploy. But for the sake of the video, I will just be showing what happens if you hypothetically deploy the entire CDK project. One of the stacks, or the stack that we were talking about, which is the IAM roles, gets created here, as you can see, and it was successfully created. And under the events, you can see all the different resources that are being created by this stack. So as you can see, there are 37 events that occurred, and all the resources are pointed out over here. So as you can see, we created this CloudWatch role. We also created the Lambda container execution role. We created the Lambda SQS checker role and the training name role. So if we just go into, for instance, the Lambda container role, we can actually see how the CDK created this resource. So as you can see, this is the role name, this is the description as I went over in the video, and also we have the permissions that the inline policies that we defined in our CDK. And as you can see, these permissions are exactly what we outlined in our CDK code. So this is what's happening in the background when we deploy our stacks. These resources are actually created. So let's go on to the next stack. Looking at the S3 bucket stack, we see that the stack name is Hephaestus S3, and we also see that the S3 bucket name is test bucket -lambda -trigger -1. If we go into the actual stack itself, it's extremely simple. We define the S3 bucket and set the name. We also define the self.bucket name so that we could use it later on in our app.py file. So switching over to the actual AWS console, we see the actual stack name under CloudFormation. We see that the stack was created, but it failed because if we go under events, we can see that this bucket already exists, which is fine. I created this bucket a while ago, so the CDK stack, when we run it again, it says, hey, the bucket already exists, and it fails. That's okay, not a problem. We can comment that out in the CDK, and it should be fine. So if we take a look at the actual bucket, we see that it was created under AWS S3. So if you come up here, type in S3, hit it, you can find the actual bucket name, and I put a sample resume.docs file. It's just a Microsoft Word document that we will be able to access in our Lambda as we outlined in the first part of the video. So let's go to the next resource. The next stack is SQS, and as you can see, this is the stack name. And if we go into the actual stack, we can see the resources that we define. First, we define the actual queue itself. We pass in the queue name, as you can see up here. And we also pass in the add to resource policy. This resource policy will define which accounts can perform what type of actions on which resources. So for instance, we can specify the accounts that can do certain SQS actions such as send messages, receive messages, etc. And you can specify exactly which SQS resources they're able to act upon. So if you wanted only, if you wanted to be extremely granular and specify the resources or the SQS that a certain Lambda or a certain account ID is allowed to utilize, then you can specify that right here in the resource policy. Now if we switch over to the actual AWS console, the first thing that we can look at is the actual CloudFormation. And inside the CloudFormation, we see the actual stack up here. Under stack, we go to Hephaestus SQS. And under events, you can see all the events that occurred. There was 12 of them. And under resources, you can actually see the resources that were created along with the actual ID. So if we go under SQS, so if we type in SQS up here, click the first one, and we go under queues, you will see the actual queue that was created by our CDK. And in here, you will see all the things that we filled out. So as you can see, the name that we defined. And if we go into the access policy, this is the actual resource policy that we defined in that CDK code. So as you can see, we define the exact principal or the exact AWS account that is able to utilize this SQS along with the actions and the resources. So let's move on to the next stack, which would be Lambdas. So in the Lambda stack, we can see the actual stack name and all the arguments that we pass to this actual stack. You can see that we're passing in the execution role that we defined up here. As you can see, IAM.lambda container execution role. So the IAM comes from the IAM stack. So like I stated previously in the other stacks, when you do self dot, that is how you identify in the actual app.py. That's how you can access those variables. So in the actual IAM roles, all the way at the bottom, as you can see down here, we defined exactly which roles that we're going to be able to utilize in the app.py. So the CloudWatch role, the container role, the SQS role, the training role. So all those roles are going to be put under this IAM variable, and then we can access it by simply doing IAM dot the role name. So as you can see, we're passing in these roles into our lambdas, and you'll see shortly why. So as you can see, these are the parameters and we're able to utilize them. So these are the three different lambda functions that we are creating, and each of these lambda functions have a role. This role is the role that we actually created back in our IAM stack, and we're going to be using them and attaching them to the actual AWS Lambda function. Every Lambda function obviously has a place where you define where the code lives. So in my scenario, all my Lambda code lives in a directory called Lambda, and inside of that directory I have specific directories for each of the three Lambdas. So as you can see, Lambda container contains the actual code, and so forth and so on. We also have the handler, which is going to be the actual name of the file. So for instance, the Lambda container, the file name is lambda_container.py. That is why I named it that. The handler refers to the actual name of the file. The runtime is Python 3.9. Obviously, you could change this. It's customizable to whatever you want. And we have the function name, which we actually get as a parameter, as I showed previously, and the timeout along with the role. So it's going to be the same for the other three. And if we hop over to the AWS console, we can take a look at the actual CloudFormation stack. If we scroll up to Hephaestus Lambda, which was the actual name of the stack, we could see in the events all the events that occurred, along with the resources that were created. So as you can see, you could see the actual physical ID of the lambdas that were created. So we created three lambdas: the lambda training, the SQS checker, along with the container. And we can go to each one of these lambdas as we define in the CDK code. The actual code displays in here. And then if we go to configurations, and then we go to the role name, as you can see, these are the roles that we created. And we go to the actual roles themselves. These are the actual Lambda roles that we created. So as you can see, that CDK code attaches the actual execution role automatically by simply, because we simply define it right here under role. So role is equal to the actual role name. So that is how we're able to attach the roles that we created in the IAM stack into the actual Lambda itself. So let's move on to the next stack. So looking at the Lambda event sources stack, we see that we pass the stack name. We also pass the SQS and the Lambda container along with the Lambda training functions. So if we go over to the stack itself, we define two events. The first event is the AWS Lambda event source, where we can add the SQS trigger to our actual Lambda function. So the first thing that we do is we call the AWS Lambda event sources construct, and we call the SQS event source, and we pass in the actual SQS resource that we created. After doing so, we call the Lambda container, which is the actual Lambda function that we created, and we call the add event source function, and we pass the event source that we created right here. The second rule that we define, or the second event that we define, is the actual cron job, which I went over at the beginning. This cron job has a rule name, as you can see, and the schedule. So as you can see, this is a cron job, and it runs every day, every month, every year at 10 GMT time. And then after we create this cron job, we have to add a target, and this target is going to be a Lambda function, and we pass in the handler right over here. So switching over to the AWS console, this is the Lambda event sources stack that we created. As we saw previously, these are all the events that were triggered along with the status. And in the resources, we can actually validate and make sure that these resources were created properly. So as you can see, we have the Lambda training EventBridge cron job along with the trigger for the Lambda function. So if we go over to the Lambda container function that we created, you can see that this SQS trigger has been added successfully. And going over to the EventBridge cron job, if you simply type in EventBridge here, go to the rules tab, you can find your cron job that was created in the CDK, and as you can see, the cron job runs every single day at 10 GMT. So as you can see that the CDK was properly created and the stack was properly deployed, and that's how you can validate that your resources were created successfully. So let's head over to the last stack, which is the API Gateway. Going into the API Gateway stack, we define a REST API with a REST API name, description, the default course pre-flight options, which essentially, in a very high overview, allows the API Gateway to be public and accessible to you and others. We set the CloudWatch role to false, as we will define the CloudWatch roles and not CDK creating a generic one. And then down here, we actually pass the CloudWatch role that we created previously in our IAM stack. And that way, the API Gateway will use this CloudWatch role instead of a generic one being created. And lastly, we will take the API Gateway, and on the root, we're going to add a resource called Lambda SQS, and then we're going to add a post method that will essentially call the Lambda SQS checker, right? So the integration is a Lambda, and we pass in the actual Lambda function that we created previously. So let's take a look at how that would look like in the AWS console. As you can see, we have the stack right over here, API Gateway, and these are all the resources that were created. Now, if we take a look at the actual resource, you can see the API Gateway was created successfully. Here is the resource along with the post request that we created, and we could see that it's connected to the Lambda. So now I'll show a quick demo of the entire system working. So let's get into that. So going into the API Gateway, which is where all of this starts, we can go to the Lambda SQS endpoint, and we go to the post, and we're going to just trigger this through the console. We can also call this endpoint through Postman, but for the sake of simplicity, I'll just test it through here. So what this should do is when I hit test, this should send a request to the actual Lambda SQS, the Lambda SQS checker, and we should see some CloudWatch logs for that. And then what that Lambda SQS should do is it should send that message to the SQS itself, and then the Lambda container should pull from that SQS, and we should see CloudWatch logs for that. So by simply hitting test here, it's going to call the Lambda then sends that data to SQS, and then SQS should then the Lambda container should pull from that SQS. And then finally, we will test the Lambda training function so we can access and talk to our S3 bucket. So if I simply hit test, what will happen is I get a successful method, there were no errors, and if we go over to the Lambda SQS checker, this is the actual Lambda function, and as you can see, we're sending a message to the SQS, and we should see a successful message. So if we go here, refresh the page, you can see we recently hit this, and as you can see at 1:48 we hit this and it was successful. This message was sent successfully to the SQS. And now if we go over to the Lambda container, this Lambda container should be pulling from this SQS, as you can see, as we set up in the CDK itself. And if we go to the CloudWatch logs, as you can see, I'm under log groups, AWS Lambda, Lambda container. We go in here, reload the page, go over here. As you can see, it was successful at 1:48. We received this message. So as you can see, what's happening is the API Gateway sends it to the SQS Lambda. The SQS Lambda then sends that data to the SQS itself, and then this Lambda, the Lambda container, pulls from that SQS, and as you can see, all of it works. Now the final Lambda is the Lambda training, and as you can see here, it will be triggered based on an EventBridge cron job. And we are simply just listing the buckets in the S3 bucket in here. And as we defined in our IAM, we should print out the contents or the list of buckets or the contents of this bucket since we have permission. So if we just hit test, as you can see, that resume.docs file that we put in earlier in the video, we get that back. So as you can see, this data was received, and everything is working properly. Now this Lambda can talk to the S3 bucket, and also it's triggered based on an EventBridge event. So as you can see, this is the power of CDK. With a simple, with a couple lines of code, you can build out this entire infrastructure, and you can build very powerful applications. You write the infrastructure once and you can deploy it many times. If there are errors, you can delete the stacks, you can debug them. You can do a lot of things with CDK, and this is just it's a microcosm of a lot of things that you can do. So if you guys like this video, please subscribe. This took a lot of effort, and I appreciate you guys. Thank you so much, and drop a like, drop a comment, let me know. And if you guys like the GitHub repo, go and follow me there and leave a like. So thank you guys.